Hi everyone, we are going to today put together what we have looked at in the last few lessons. So looking at graphing any of our transformations for y equals sine x. We know that we can graph y equals sine x, our base graph, very easily using the 5 key points. And we can always create our table of values, or we can write them as points. But when we're talking about that, we're talking about every 90 degrees. So we start at 0, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So we know that y equals sine x starts at 0, goes up to 1, back to 0, down to -1, and back to 0. So we can graph that very quickly. If we want to graph just one cycle, we have y, x, and every 90 degrees, we know we can graph this very quickly and easily. So starting at 0, up to 1, back to 0, down to -1, and back to 0. So we have our nice smooth curve. Remember, it's not a direct, it's a curve. And we have our graph of y equals sine x, okay? And we can remember our base properties. Amplitude is 1, period is 360 degrees, max is 1, and min is -1. So we want to keep all that in mind when we are looking at our transformations. So when we have the equation of a sine function, we know that the a value is a stretch or compression vertically. So this is going to change our amplitude. It's also going to change our max and min. It could also be a reflection if we have a negative out front. And sorry, that's not writing there, but that's reflection. So that means a reflection in the x-axis. The b value in here is a horizontal stretch or compression, and that's going to change our period. Our h in here is our phase shift, and is going to shift our graph left or right. And remember, if it's a minus in here, it is going to shift to the right because we're subbing a positive value in. Shift to the left if we have a negative value. And just a double check here, we know that our compression, horizontal stretch or compression, does the opposite as what it appears. It stretches if it is a fraction, 1/2, 1/3. It compresses if it is a whole number like 2, 3, etc. And finally, our k value at the end here is our vertical translation. And that means it's going to shift it up or down. And again, that's going to change our maximum and minimum. So if we change the equation to y equals sine x plus k, we know that the period stays the same, but the graph moves up or down. So it's going to change our max and min. If we change and we put an a value out front, just like we just talked about, it's going to change the amplitude. The amplitude is going to be the a value, the positive a value. It can also be referred to as a vertical stretch or compression. If we change the value inside with x, we know that our period is going to stay the same. But the graph moves right if it is x minus h, left if it turns into x plus h. And this is also called a phase shift. Finally, if we have a b value in front of x, it is going to change the period or the horizontal distance for one cycle, and it's also referred to as a horizontal stretch or compression. So again, keeping all of those things in mind as we take a look at some graphs here. So we're going to graph one cycle of each of the following. Now note that it's best to graph our stretches or compressions first, and then we can look at the shift or vertical translation, phase shift and vertical translation. So if we're going to graph y equals sine x plus 1, we know our amplitude hasn't changed, so our amplitude here is just 1. Our period has not changed, nothing in front of x, so our period is still 360 degrees. There is no phase shift, and our vertical translation is up 1. So we know that our max of 1 now goes to 2. Our min of -1 now goes to 0. So we need to have our y-axis as 0 to 2. And our x-axis, we just need to go 0 to 360. So we're going to make this 1, 2. Remember, we still want to label the entire grid just because we're not using the whole thing. So we just need to go to 360, so let's make every 4 blocks 90. We know our key points are still going to stay the same as well. And note that we don't always have to have all 4 quadrants in our graph. We don't necessarily have to show the left-hand side of this graph if we want to set it up that we just start closer over here with our y-axis. That's fine as well. So this one is pretty straightforward. We don't have any stretches or compressions, so we're just going to shift our base graph. Remember, our base graph we can plot very quickly, again using a dotted line because that's not our final graph. Now we're just shifting it up 1. So we're going to start, instead of 0, 0, we're going to start at 0, 1. And every 90, we're going up 1 unit, or just shifting all of those key points that we've graphed on our base graph up 1. And there we have our graph of y equals sine x plus 1. Okay, next one, we are shifting right 30 degrees. So amplitude has not changed, period has not changed. There is a phase shift right 30 degrees, and there is no vertical translation. So we know our max and our min are going to stay the same, which is what we keep in mind when we're graphing or scaling our y-axis. So we can make this pretty big as far as numbering our y-axis. We know we need a phase shift right 30 degrees, which means that we want to have our blocks in values of 30. So we're going to actually make our x-axis, we're going to go up every 3 blocks is 90 degrees. Again, We do this so that we can do our phase shift of 30 degrees very easily. Okay, so again, our base graph using our key points would look like this. Now all we're doing is shifting to the right 30 degrees. So we're going to move all of those key points over 30 degrees. And this is our actual graph, so we're going to put our thick lines in here, our arrows on either end, and here we have our phase shift right 30 degrees. Next one, we have a few different translations here, or transformations. So our amplitude, again, because we're measuring a basically height of our graph, that's our A value out front. It has to be a positive value. Now that negative does tell us that there's a reflection in the x-axis. The period, remember that this is a compression by 2, so our period is going to be half of what it was before. So our period is only going to be 180 degrees. No phase shift and no vertical translation. So we know that our max is going to be 2, min is going to be -2 because we have a stretch by 2, but we have no vertical translation changing that. So we're going to label 1, 2, we need to go down to -2. And again, we're going to keep in mind our period is only 180. Our key points are going to happen every 45 now, half of 90. So let's take a look, 2, 4, 6. We have at least 18 blocks, so we're going to go up by tens. So we're going to have, or actually, if our key points are going to be 45, let's go 45 every 4 blocks. So we want to keep in mind where our key points are going to occur as well. So we're going to now plot our key points. And again, we know that those key points are going to happen every 45. We have no phase shift or vertical translation, so our original starts still at 0, 0. Now, what we have to keep in mind is this reflection. So if we want to, we can plot without the reflection first. So we have a stretch of 2, and our key points are half as far as they were, so 90 to 45. So this is going to be the graph without a reflection of y equals 2 sine 2x. Well, now we have a reflection around the x-axis, which means that all of our positive y's become negative y's. So this one up here flips down to the bottom. Our zeros are going to stay the same. This one here flips up to the top. So instead of starting and going up from 0, we're now going to be going down from 0, and we have our graph of y equals -2 sine 2x. Next one, we have y equals 3 sine x plus 45 minus 2. So our amplitude here, again, just our a value, positive a value from out front, we are going to have an amplitude of 3, which means actually let's talk about our max and our min in a second. Our period, nothing, the b value is 1, doesn't change anything. So we still have a period of 360. We have a phase shift to the left, this time 45 degrees, and our vertical translation is down 2 units. So this, we have to keep in mind, our max was 3, but we take away 2, means our maximum is 1. Our minimum was negative 3. Taking away 2 means we're going to go down to negative 5. So to plot or label our axes, we know we're going to have to go up to 1, down to negative 5. So we want to make sure down here we've got enough space to get to negative 5. And again, we don't necessarily have to label every single one. We're also going to go for our x-axis left 45. So we want to make sure we know exactly how much 45 is. So if we want to go every 2 blocks is 45, means we're going to go every 4 blocks is 90. And our key points are still going to be every 90 degrees because we don't have any horizontal stretch or compression. So starting with our graph of y equals 3 sine x, just our stretches and compressions first of all. So key points are going to happen every 90, starting at 0, going up to 3, back to 0, down to negative 3, and back up to 0. So this is y equals 3 sine x. Well, now we want to shift this whole thing down 2 units and left 45. So our original point here comes down to here, and we can do this point by point, or we can use key points. We know that we can use key points as well. This one is going to come again down 2 units, left 2 blocks, down 2 units, left 2 blocks, down 2 units, left 2 blocks, etc. And remember, it's not necessarily blocks, it's amount. So we want to know what our values are. So now we can draw our nice curve through our points, and we now have our graph of y equals 3 sine x plus 45 minus 2. Next one, our amplitude for this one is 1/2. Notice our period is 1/2, or our b value is 1/2. We are going to be stretching by 2. So we're going to have 360 times 2 means our period, or 1 full cycle, is going to be 720. Phase shift is right, 30 degrees, and our vertical translation is up 3 units. So again, thinking about how we're going to scale this, and notice we have a different graph here, a different grid. As I mentioned before, we don't have to show a lot of the left side if our full cycle is going to be on the right hand side. So we're going to label this, our amplitude is 1/2. So normally we would go 1/2 to negative 1/2. Here we're going to have our max of 1/2, but we're going up 3, which means it's going to be 3.5. Minimum value was -1/2 plus 3 means it's going to be 2.5. Okay, so we could also have scaled this a little bit differently as well, in that maybe we wanted more space up in the positive y values. We need to go 3.5, 2.5 to 3.5. So we are going to go by ones on our y-axis. And we're going to phase shift right 30 degrees. So we want to make sure that we can move 30 degrees easily. So we're going to make every block 30 degrees, which means every 3, we want to make sure that we have enough space for 720. So 270, and actually we want to go to at least 750 because we're going to add 30 here. So we want to go to at least, just making sure that we're going to have enough space. We're going to have just enough. So just first of all focusing on so no translations first. We're going to start with our 1/2. So we would start at 0, 0, and our key points are going to happen every 180. And we're only going up to 1/2. So 180 back to 0, 180 down to -1/2, and back to 0. So we have our graph of y equals 1/2 sine 1/2 x. Now we have to go right 30 degrees and up 3 units. So we're going to go up to 3 and over, and this is going to be where we're starting. So each of those key points, 1, 2, 3, and over 30. 1, 2, 3, and over 30. 1, 2, 3, and over 30. And 1, 2, 3, and over 30. And there's our graph of y equals 1/2 sine 1/2 x minus 30 plus 3. And part F, we have an A value of 1, amplitude stays the same. We don't have any horizontal stretch or compression, so our period is still 360. We have a phase shift right 90 degrees, and we have a vertical translation down 2 units. So our max is going to be still 1. Min is -1. What we have to watch here is this is going to be a reflection. Okay, so we have to keep that in mind. Now, we are going to just go up to 1 and down to -1. We have to phase shift right 90, so we want to make sure we know exactly how much 90 is. We're going to go over 3 blocks is 90, keeping in mind that we need to go to 360 plus 90 or 450. Okay, and again, plotting first of all our, let's say our y equals negative sine x. Okay, so normally we would go to positive 1 at 90. Reflection in the x-axis means that we're going to go this way instead. So this is y equals negative sine x. Now we're going to apply our translations. So from our original point here, we're going to go down 2 units. And wait a second. We've got to rescale our grid. Okay, so demonstrates how we want to make sure that we have our vertical translation attached as well. So let's take a look at this. And this is a good point. You can always just change your grids as well. So our max taking away 2 should be -1. Our min taking away 2 should be -3. So we are going to fix up our graph here. So if we have to go down to -3, we're going to make this -3, +3. Doesn't change our period. We're still going to move over 90. But our original graph, we're again using our reflection still, just means that we're going to make it a little smaller height-wise on the grid. So changing this to y equals negative sine x now, shifting down to right 90. Each point down to right 90, down to right 90, down to right 90, and so forth. And again, keeping in mind how we have scaled the graph. And there's our graph of y equals negative sine x minus 90 minus 2. Now, keep in mind as well that you can use Desmos to check and make sure that you've got the right graph once you've graphed it. Don't forget that you can change your settings using the wrench at the top right-hand corner of Desmos to double check that your graph is correct, okay? And change your scaling and so on and so forth. So that's kind of putting everything together. As always,